Hello, my name is Joachim, and in this video I'm going to show you how I made a colorization model in Perceptilabs. Now there's quite a lot of examples out there on the web already doing the same thing, both in PyTorch and in TensorFlow code. But I just wanted to make one in Perceptilabs as well. So for the training data, I use the same colored images as input and the same one for the target. So instead of having one set of images, black and white images, and another set of colored images for the target, I simply use the same images and convert it to black and white here. And I use a custom component for that, which I just take the input colored image, convert it to YUV color space, and slice out the Luma channel or the Y channel. And in the next layer, which is also a custom layer, I add some Gaussian noise with a standard deviation of 0.1 to make the training more stable and also prevent overfitting. Then in the next layer, I scale it down to 64 by 64. And one reason for that is that training this model in the full resolution requires quite a lot of GPU memory, which I don't have. I only have a 4 gigabyte GTX 980. So fortunately I cannot train high resolutions without going down in batch size, which is not optimal. And also, since we perceive colors in the lower resolution than grayscale, we can still get away with it pretty good. This is then fed to a unit with 2 number of labels. Yeah, you can't see the settings on this here because I've changed in the code here. What I did was I added two levels. I made it deeper. But other than having sigmoid as the output activation, all the other settings are the default ones. So yeah, that's that. And then I feed it another custom layer, which just does one thing, and it's just subtracting 0.5. And why it does that is, I will get to that just in a minute. But that's all it does. It just takes the input and subtracts 0.5 from it. And then I scale it back up to 224, same as the input. And then I have this merge component here, in which I concatenate all the channels back together. And in the final layer, I convert it back to RGB, and that's the reason I had to subtract 0.5, is because that the U and V component are in the range of 0.5 to minus 0.5, and since the UNet has a sigmoid activation on the output, which is between 0 and 1, I need to subtract 0.5. So it gets within the range, because if I don't do that, the model won't train. You will just have a spike in the gradients and then it's dead. But yeah, that's pretty much it. Thank you for watching.